Hey, year 10s. Thanks for coming along, guys. It's great to see you all. I feel like I haven't seen you guys in ages. No idea why. Oh, no, I do. We missed a lesson, didn't we? That's why. I do remember. I do. Okay, sorry. I'm just checking that the sound's okay on the stream. We're just missing 5 people now, maybe even less, maybe 3. We are missing Zihan, Fatima, Ryan, Oleg, and Mary. That's the only people now missing. How is everyone doing? Is everyone all right? There's Fatima. Fab. Guys, just so you know, today's lesson, we're going to be looking at balancing equations. Now, I know that you guys did it as an exercise in class. I hope it went well. You obviously had the mark schemes then to be able to mark your own. But all I'm going to do is I'm just going to quickly review it. I'm not going to review the homeworks, not going to review the exercise. But I'm just going to talk through a couple of balancing equations just to offer you guys a couple of suggestions on how to go about doing it. It's also nice to point out the number of questions that you're going to have in your GCSE exam, which is 1. Yeah, because you guys only sit 1 paper. So you guys are only going to have one question on balancing equations, and it's going to be a doddle. Yeah, it's going to be easy. So I'll just go through a couple of methods to help people. Hi, Mary. Great to see you. Got Mary here. That's great. Just missing Zihan, Ryan, and Oleg now. Come on, guys. Come on, there's Oleg. Whoop, 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 whoop. Just got Ryan and Zihan now. Ryan and Zihan. That's it. We're nearly finished with the register already. That's amazing. I'll give them 2 more minutes and then we can crack on. So as I said, today we're going to be looking, I'm just going to do a couple of balancing equations. I'm not going to spend a vast amount of time on it. If people want a homework that we can then go through in the over the webinar, more than welcome to do so. I realize that balancing equations is something that I realized very quickly on as a teacher of chemistry, that some people find it really easy and they kind of pick it up really quick, and then other people just require a bit more practice. So if you need the practice, I can give it to you. I have got so many balancing equation sheets that'll make you feel ill. Yep. So, and then we're then going to go on to reacting maths questions. And these are the hard ones, guys. These are the big ones. And I will do this in a process. I'll set you a homework for next lesson, but I promise you guys it'll be absolutely fine. And we'll get, oh, hi, Jess. Thanks so much for coming. Hi, Mr. Duncan. Are you 10s? That's lovely. Lovely to see you, Jess. Right, what I'll do is I'll mark Ryan and Zihan as missing for now, and then I'll add them to the register later, and I'm going to crack on with my lesson. Lovely to see you, Jess. Right. Okay, just detaching my keyboard. Get rid of my keyboard. Z is coming. Excellent. Glad to hear it. There. Okay, cool. So share screen. Let's crack on with today's lesson. I like it. Hide. Okay, so it's one of my A2 lessons, that one. We want this one. I love it. Perfect. Zihan. Hi, Zihan. I'll mark you in on the register. Thanks for coming, dude. Just Ryan missing now. I'll mark him as missing, and then I'll add him on when he arrives. Oh, definitely too thick there. Okay, so I had to reset my Wi-Fi. No problem at all. Okay, so guys, today we are just going to be looking. Our main title is reacting masses. Yeah, reacting mass questions. Reacting mass. I'll put questions. Just put reacting mass. So my learning objectives for today's lesson, I'm going to add one that's not on the YouTube channel. I'm now trying to get into the habit of adding my learning objectives onto the YouTube channel. Kind of makes sense. But I'm just going to add in an extra one. I'm going to put be able to balance equations. Yeah, balance equations. Yeah, we'll talk about that as well. Just to let you know, you guys I think all know I'm actually a double scientist myself. Yeah, I did double science. And now I'm an A-level chemistry teacher. So, this will not impact your ability to take A-level. And if you're thinking of taking A-level, please let me know. And I'll link you guys in. I'll send you the links to the webinars that go all the way to the end of triple science. I can add those give them to you so you can watch them if you wish. Be able to balance equations. That'll be the first one. And then the next one is knowledge. I need you guys to know the steps in reacting mass. In reacting mass calcs. I'll put calcs up there. That's what I want to put. Reacting mass calcs. Next one is I need you to understand the mole ratio. Ratio. You got to say the word ratio. You have to say with a rolling R. Mole ratio. Just like that. That's how you got to do it. Yeah, I'm just letting you know. I mean, it's part of chemistry. The next one is another able to. So we've got an able to, yeah, a knowledge, an understanding, and another able to. And I want you to be able to do exam questions on it. So this is just me just highlighting that. I'm going to do that by the end of the lesson. Okay, so the first thing I want to do is I just want to quickly look at some balancing. Yeah, I know that you guys have done this with Miss All Day already. I'm just wanting to fill in the blank if there is any. There probably isn't. Just want to offer you some suggestions for balancing. So first thing I think we should probably note is that number one, we don't balance word equations. Don't balance word equations. And in fact, that is why, don't balance word equations, that is why there is a limitation to it. It's why you can't use them to do any calculations. Yeah, so we can then say as a consequence of that, we only balance symbol. Yeah, now the next bullet point I want to add to this is, so why are we balancing? Yeah, and it's a question really, isn't it? So question is why balance? Why balance equations? Now, there's two answers to this, and I'm very aware that you guys are double award, yeah. But today's lesson, I'm teaching you guys at a good level here, so I want to give you the real answer and the other one. It's not like it's not real. Why balance? Question mark. And the answer to this is number one. Yeah, first point, which is what you would actually write down in your GCSE exam. Yeah, the first one is that you would say conservation of matter, of mass. Conservation of mass. Yeah, and what that of course means nothing to people. It's just a load of words. What this means is every atom in must come out. Must come out. You can't lose atoms. Yeah? And this is why mass adds up. Yeah? So there is a second reason for this. Yeah, the second reason why we balance. This is answer number one. Answer number two, and this is more today's focus, yeah, is to find mole ratio. And that's the first time that mole ratio, yeah, to find the mole ratio. This will make more sense by the end of the lesson. I'm just going to star that because I'm going to revisit that one, yeah, at the end of the lesson. Yeah. So at the end of the lesson, we're going to come back to that point, and it'll make total sense, I promise. Okay, so let's now do a balancing equation. Let's start simple and get harder. Seems very reasonable. Yeah, start easy, get hard, and I'm going to offer you a method. So, and I don't want to rush, guys. If I'm going too fast, just pause the video, make the notes, and then continue it. It's not a problem. Yeah, I'm just going to give you some examples. So question. So let's look at this equation. Hydrogen plus oxygen goes to water. Let's balance this equation. So what we need to say here is that every atom that goes in must come out. So really, what they're testing your ability here is your ability to count atoms. So let's quickly put a question onto the chat. So I'm going to put this question to, this is to Bo Yang, Chi-Mun, and Kate. Can you tell me how many atoms of hydrogen are there? I'm then going to give the next question to Natanya. So this one is how many atoms, and that's to Bo Yang, Bo, Chi, and Kat. Yeah. And the next question is how many atoms of oxygen are there? I'm going to give that one to Nat. I'm going to give it to Ethan. And I'm going to give it to Adri. Yeah. And the next question over here is, there we go. Oh, love it. Kat, Chi-Mun, well done. Yeah, two, well done. Nat, well done. Oxygen 2, great job. That's really nice. Boyang, I know that if you're taking your time, don't worry about it. You can always, pick this up later. Well done, good job. So, okay, so this one, so that's easy. Everyone's on this. Everyone understands that this number 2 relates to the guy before it. That's great. So, okay, then this is going to get steadily harder. So, okay, what about water? So, how many atoms of hydrogen and how many atoms of oxygen are in water? Boyang, thank you so much. That's great. I'm going to ask Kat and Chimon again, how many atoms of hydrogen? And then I'm going to ask Adrian Oleg, how many atoms of oxygen? Yeah, I'm just going to pick people. I'll move through the people. Obviously, the more to go, I'll do Amber and Fatima and Mary next, and Oleg. So for hydrogen, I'm going to give you a slightly trickier one in a second. Kat, well done. 2 hydrogens. Spot on. I like it. How many oxygens are there? 1. I like it. You guys know what you're doing. Okay, so everyone's okay with this. You guys are able to read formulae. That's great. So now we need to come to balancing it. So the first thing I do whenever I balance an equation is I split the equation in half. I just like to draw that line over the arrow. It makes me easier in my head. So what I'm going to do is we now need to know that everything on the left, all the atoms in, on the left, and this is the atoms out on the right. I should, you know what? I should put in, and then out. They need to add up. They need to be the same. So now what I tend to do is I'm going to teach you the base method, and then you can learn to not use it anymore. What I now like to do is to box everybody. Now here's the rules. I like to draw boxes around everybody. Here's the rules. You cannot change what is in the box. You can only add more boxes. So what I'm now going to do is, and this will make sense by example 3, we're done. Would everyone agree? I've got 1 box here, 1 box here, and 1 box here. Right. How many hydrogens in the first box? 2. How many hydrogens in the box on the right? 2. I started with hydrogen and I checked left to right. Next, how many oxygens on the left? 2. How many oxygens on the right? 1. Right, that doesn't add up. What I'm now going to do is add another box. On the other side, the number is not giving me enough. So I only had 1, so I'm going to add another box. And the box is just writing down water again underneath it. So I've now that I've done this, I now need to start again the process of counting. So I'm going to make the green vanish and the purple. Right, let's count them. Hydrogens, 2. Hydrogens, 2, 4. I've got 4 there now. Right, so now I've got to add another box onto this side. I'm going to add another box. I'm just cloning the boxes. The boxes is just a clone. Right, start again. I made a change. Right, hydrogens in. 4. Hydrogens out. 4. Oxygens in. 2. Oxygens out. 2. My equation is finished. I now rewrite the equation and I count my boxes in front. 2 boxes of hydrogen. 1 box of oxygen, you don't need the 1 in reality, goes to 2 boxes of water. And my equation is done. Boxes are I call these balance boxes. And they're really useful. And you know what? It's really funny because when you get to A-level and you get hard questions, there are times when I still go back to this. It just helps because it allows you to see everything better. Let's do another one. Question number 2. Let's make the question get steadily harder as we go on. Let's go for, I'm trying to think of one that's, okay, aluminium plus oxygen goes to aluminium oxide. Right, so they're going to ask you to balance this one. So step number 1, draw your line down the middle, break it in half. Step 2, add your boxes. Just draw a box round each individual person. Next, count the people in the boxes left to right. Aluminium, 1. Aluminium, 2. Add a box. Can't change what's in the box. Just going to add another box. Clone it. It's a copy. Yeah, this is just a flat copy. Right, start again. It gets quicker, by the way, the more you do it. 2 aluminiums on the left. 2 aluminiums on the right. We're good. Oxygens. Oxygens on the left. 2. Oxygens on the right. 3. Doesn't add up. Add another box. Right, this side had 2. This side has 3. Add a box to the side with less. I'm going to add a box here. Right, let's count again. Start again. Start again. Aluminium, 2. Aluminium, 2. Oxygen, 4. Oxygens, 3. Oh, doesn't have enough. 4 and 3. Add another box. Al2O3. Clone it. Next, start again. You get quicker as you do it. 2 aluminiums. 4 aluminiums. Add more boxes. I need to get from 2 to 4. Each box contains 1. I'm going to add 2 boxes. There we go. Make it the same. Next, aluminiums. So close. Aluminiums. 4 on the left, 4 on the right. Oxygens. 4. Oxygens. 6. Add another box. Start again. Check them all again. You do get quicker. Next. Aluminium. 4. Aluminium. 2, 4. We're good. Oxygens. 2, 4, 6, 3, 6. It all adds up. I'm finished. Count my boxes. 4 boxes. Said it wrong. 4 boxes of aluminium plus 3 boxes of oxygen goes to 2 boxes of aluminium oxide, and I'm done. So I just wanted to show you that, guys. It takes a bit of practice. You're only going to have 1 of these questions in your GCSE exam, which is great. Just do the boxes. You'll be done in under a minute. Yeah, it takes about a minute to do each one. You get used to doing it. You don't even need to draw the box in reality. Show you how this evolves. Yeah, I'm going to do question number 3. So question 3, let's go for iron plus chlorine goes to iron 3 chloride. Let's do that one. Right. Iron, 1 and 1. Chlorine, 2 and 3. Add a box. Yeah, add a box. I'll draw the little line in the middle as well. There we go. Add a box. 4, 3. Add a box. 6, 4. Add a box. Right, chlorine's now balance. Right, chlorine 6. Chlorine 6. Iron, 1, 2. Add a box. Check it. 2 here, 2 here, 6 here, 6 here. I'm done. Count your boxes. 2 irons plus 3 chlorines goes to 2 iron, 3 chlorides, and we're done. There you go. So after a while, this gets quicker. You can do it in under a minute. It just takes practice. If you want to have a go at those homeworks again, please do. You do the ones that you got wrong. See if that makes it any easier. Yeah, sometimes you do get a bit stuck on boxes. You learn after a while, you stop doing the boxes and the boxes just kind of disappear. But it's just nice to show you that boxes can be very useful. At GCSE, it will always work, which is always a great one. Okay, so balancing, we can go back to our learning objectives. We've covered a bit of balancing equations and you guys can have a go. Can I ask a quick question on the chat? Have you guys seen balanced boxes before? Just put on the chat if you've seen them before. Okay, next. Right, guys, here's the big one. We're doing reacting maths now, folks. My writing got really big, really fast. Right. New title. Nope. Oh, okay. Never seen balance boxes. Okay. Do you guys like the balance boxes? Do you think it could be useful? Reacting mass calculations. Okay. Yeah, I think so. Good. Okay, glad you liked it, Kate. Good. Thanks, Adri. Glad to hear that. we usually use a table. Oh no, I hate the table. I don't like the table. Yeah, I get it. I know exactly what you're talking about. Fair enough. Okay. Right. Reacting mass calculations. So this if you use a table, you'll be there for, oh, I'll stop. Reacting mass calculations. Okay, folks. So what we now need to do is we're going to have a learning objective specifically for this one. Know the steps. Now, the way I teach reacting masses is through questions. Yeah, through questions. So question number 1. Because the reason why is because I need you to recognize when the questions occur. If you don't recognize the questions, then you can't answer them. So the question would say, it would give you an equation. Let's stick with the hydrogen and oxygen one. I like that to make water. It's nice. It's nice. And they will have already balanced it for you. How nice is that? It's always nice. Yeah, and they're going to say to you, here's the question. Kate, I nearly wrote Ekaterina. Kate has 100 grams of hydrogen. Has 100 grams of hydrogen. What mass of water will she make? That's it. So what's happening here? Trying to recognize these questions, as I said, is a skill on its own. That's why you have to do exam papers to be able to do that. But this question here of how much are you going to make? The key words, yeah, mass and make. If you see those, your chances are you're in a reacting mass question. So what we now need to do is we now need to do steps. Okay. So steps in reacting mass. I'm going to put that in a bubble. Steps in reacting mass. Okay. Now, I teach this the same way that I kind of do in A-level, but the great thing is you guys already have steps done for you. So step number, oh, I know what, I'm going to shorten it. I'm going to shorten it to what I do at GCSE. I'm just going to shorten it. So step one is get to moles. Okay, so, and this is a little bit tricky, I guess. The reason why you have to get to moles is because to use an equation, you chemists work in moles. You can't use grams. So the first thing we realize is we've got one moles equation. That's all you guys have in double science, just one. You don't have any more, which is great. In triple, they have 3. You guys have 1. And you guys go, oh, step number 1 is number of moles is grams over rams. You guys did it on your last homework for me. This is why you did moles, and then we go into reacting mass. Yeah? This equation is so important. Moles is grams over rams. Yeah? Grams over rams. So the question is, who do we have grams for? Right. So step number 1, I'm going to try and color code this. Step number 1 is green. I have 100 grams of hydrogen. Right. So I'm going to have to get to the answer of that. So I'm going to go, moles of hydrogen equals grams 100 over. Now, what does hydrogen weigh? Now, you've got to be careful here because hydrogen travels around in pairs. Yeah. So hydrogen weighs 2. This is why we did working out relative molecular masses in the homework before moles. Yeah. So hydrogen on the periodic table is 1, but that's a terrible hydrogen box. Yeah. Hydrogen is 1, but it's in a pair. So we're going to times it by 2. Final answer is 2. That's nice, isn't it? So I have been given, Kate has gone and bought 50 moles of hydrogen. Get to moles. Right. Step number 2. Step number 2. Oh, shouldn't do it in green. Step 2. Use mole ratio. Right. Now, what is the mole ratio? The mole ratio is the posh word for the balancing numbers. Yeah? So in this is where I'm going to star it. Yeah, star it with a color. Yeah, so I'm going to do this one in purple. So where's the mole ratio? The mole ratio is 2 to 1 to 2. There's my mole ratio. Yeah, my mole ratio is a 2 hydrogens to 1 oxygen to 2 water. There's my mole ratio. It's the big numbers that I balanced with. Now, it says in the step, use it. Well, what the mole ratio says, what this says, it says 2 moles. This is where I need to color code everything. Not a great choice. 2 moles of hydrogen react with 1 mole, react with 1 mole of oxygen, purple, to make 2, change my color again, to make 2 moles of water. That's what it says. That's literally what the balancing equation says. Now, here's the thing. What did I just work out I had? I had 50 moles of hydrogen. So I didn't have 2. I had 50. How do I use the ratio? Well, what was the question asking me for? The question says how much water. So I'm going to go from here to here. Now look at the ratio. The ratio is a 2 to 2. Those numbers are the same. What that means is if she uses 50 moles of hydrogen, she's going to get 50 moles of water. So the number is the same. Yeah, it's the same because these two are the same. We'll come to oxygen in a minute. We'll come to a harder example in a minute. So we just copy the number over. Use the ratio. 2 to 2, 1 to 1, 50 to 50. That's how that's just gone down. Right. Step 3. So what we've now got to, step 3, is get out of moles. Same equation. Number of moles is grams over rams. But what I now want is mass. Reorganize for mass. Bring rams over. Rams times moles gives me grams. Right. So what we've now done, I'm now going to bring all of what we've done together in one step. So we've got this plus this goes to this. Here's what we have just done. We said, I've got 100 grams of hydrogen. Step 1, get to moles. Yeah, moles. Number of moles is grams over rams. 100 over hydrogen, which is therefore 2, because it was 1 times 2. Yeah, so I've got 50 moles. Step number 2, use the ratio. Step 2, ratio. The ratio from hydrogen to water was a 2 to 2, which is 1 to 1. So 50 to 50. Yeah. Now get step 3. Get out of moles. Out of moles. Right. And I need to reorganize my equation. So I need to times 50 by the weight of water. Now notice the number 2 has already been used. The 2 has been used in step 2. What does water weigh? Water, hydrogen is 1, but there are 2 of them in it, plus oxygen, which is 16 times 1, giving me a weight of water of 18. So I'm going to multiply 50 by the weight of water, and I will get 50 times 18, and I get 900 grams of water, and we're done. I know it seems, by the way, this is a very straightforward process. Yeah, 3 steps, and with you guys having only one equation, this becomes really easy. It's just practice. Right, guys? What we're now going to do is now going to have a go at question number 2. Same thing, we're going to talk it all the way through. Okay. Can I just quickly ask, everyone still here? Did everyone follow? Does everyone understand what I'm doing? Just give me a thumbs up if you understand what I just did. If you don't, give me a thumbs down. I think that's very reasonable. I like it. Brilliant. Question number 2. 85%. Good job, Kate. I promise you, by question 3, you'll be on 100. And you'll be able to do all of these on your own. This is great. Got 5 people on the chat saying, I'm on it. Great job. Right, question number 2. Let's make it harder. Yeah, let's make this harder. Hydrogen plus chlorine goes to hydrochloric acid. You're going to be given the balanced equation, which is great. Right. I'm going to, let's go Kate. No, let's use a different person. Let's use Z. Z has, let's go for 100 grams of chlorine. 100 grams of chlorine. How much? What? They won't say how much. What mass of HCl will he make? Question mark. Like it. Okay. Step number 1. As soon as you see how much we're going to make in mass, it's telling us. Yeah. So, guys, what I'd like you to do is pause the video and run the steps and then forward it to see if you get it right. So, step number 1. By the way, I always like to rewrite the equation. Because I like to write things underneath it. It just, for me, it always made more sense. Yeah. So, step number 1, get to moles. Find moles. Right, what do I have? 100 grams of chlorine. Perfect. I'm going to do this in a different color. 100 grams of chlorine. I'm going to write 100 there. Right. So I've got 100 grams, and I need to do step 1, get to moles. Yeah. Number of moles is grams over rams. Write that equation down every time. Right. Start putting in your numbers. Number of moles equals 100 grams. How much does chlorine weigh? Oh, chlorine on the periodic table is 35.5, but it's in a pair. So chlorine gas, yeah, weighs 35.5 times 2, weighs 71. Grams over rams. Chlorine gas, for those people who aren't going to be too sure, just for me to make my notes a bit clearer. Yeah, brackets Cl2, 71. Right, run it through my calculator. Just going to get rid of that there. Yeah, right. 100 divided by 71, the relative molecular mass of chlorine. Okay, in purple, I have got 1.408. Now, what you always do is 3 significant figures at GCSE. 141 moles. But I'm going to keep the real number on my calculator, which is on my calculator, it says 1.408450704. I'm going to keep that number on my calculator. Right, now that I've got to moles, I'm now going to use step number 2. Use the ratio. So what's the ratio in the equation? The ratio is an invisible 1 and a 2. I like it. The ratio is 1 to 2. Oh, I'm going to move that over a little bit. There we go. I could, by the way, if you want the full ratio, yeah, the full ratio for this equation, of course, is 1 to 1 to 2. But in reality, I don't really care about the hydrogen. I didn't ask about it. Yeah, the full ratio is that, hydrogen to chlorine to HCl, but I don't really need the hydrogen. I just need the HCl. And that ratio is a 1 to 2. So how do you use step 2? How do I get the number 1 to the number 2? I'm going to multiply it by 2. So if 1 becomes 2, I'm going to multiply that by 2 as well. Right, so on my calculator is the real number. Times 2 gives me, zoom in, times by 2 gives me 2.82 to 3 significant figures, but I've kept the number on my calculator. Right, I've used the ratio. Now all I've got to do is get out of moles. Step 3, get out of moles. Number of moles is grams over rams. Reorganize. Number of moles times by rams gives me grams. Right, I've got moles. What's the relative molecular mass of HCl? H, of course, is 1 plus, and it's times 1, plus chlorine, I'm just going to do that there, plus chlorine at 35.5. The total weight is 36.5. So I'm going to do 2.82 multiplied by 36.5. I've kept the number on my calculator, times 36.5 gives me an answer of 102.8 grams. Amazing. Cool. I like it. Right. I promise you, after a while, this gets easier. You just realize it's the same routine every time. Yeah, it's just the same routine. You practice it, you get better, you reinforce it, you remember it. Yeah, this is all about practice, and hence why your homework is going to be reacting mass calculations. Shall we do question number 3? Let's do question number 3, everybody. Let's switch back to black. Okay, question 3. Okay, question number 3. Let's go for aluminium plus oxygen goes to aluminium oxide. Right. The equation will already be balanced for you. Yeah, it will already have it done. I'm giving you this because it's a hard ratio. Yeah? Okay. I should stick with an easier one, shouldn't I? Let's go for an easier one. I'm going to give you an easier equation, guys. Let's go for iron plus chlorine goes to iron 3 chloride. Yeah, so that becomes a... is that going to be exactly the same ratio as I did before? No, it doesn't. It's still awkward. Still awkward. Don't like it. I'm trying to look for even numbers, if you're wondering. Just looking for even numbers. Let's do methane plus oxygen goes to carbon dioxide and water. Complete combustion. Let's go for that. Right. Balance it. 1 carbon, 1 carbon. 4 hydrogens. 4 hydrogens. I'm going to draw the line. Yeah, 4 hydrogens, 4 hydrogens. That makes sense. Right, carbons 1, carbons 1. Hydrogens 4, hydrogens 4. Oxygens 2. 4. Need another box. That all adds up. All adds up. Count my boxes. 1, don't need it, but I'm putting it there anyway. 2 boxes there. 1 box there. 2 box there. Like it. Okay. Let's get rid of that. Balanced equation. Okay. Mr. Duncan burns 250 grams of methane in class. What mass of carbon dioxide carbon dioxide and water did he make? Question mark. Right, so now I'm giving you multiple people. It doesn't make any difference. The process supports it. Let's rewrite the equation because I find it handy. Yeah, it's always really handy. Heck, I'm going to do oxygen as well. I'm going to do the lot. I'm just going to do everybody here, folks. I want to show you something. Okay, and I'm going to do oxygen last since it's not in the question. Step number 1. Step 1, get to moles. Grams over rams. And I have 250 grams of methane. How much, by the way, I should write down the equation. Step 1, moles. Moles. That's the Christmas version of moles, by the way. Number of moles equals grams over rams. Right. Number of moles is what 250 grams over what does methane weigh? Yeah, what does methane weigh? So methane, carbon is 12 plus hydrogen at 1 times 4. It weighs 16. Perfect. So weighs 16. My number of moles, therefore, just going to get rid of that. My number of moles, therefore, becomes 250 divided by 16. 15.6 moles. 3 sig fig, kept the real number on my calculator. Yeah, just kept the real number on my calculator. 15.6 moles. I'm actually going to write the word moles right underneath it. By the way, the units for moles is mole. Yeah, mole. Right, what's the ratio? 1 to 2 to 1 to 2. Right. If I want oxygen, times it by 2. So I'm going to times that number by 2. Gives me 31.3 moles of oxygen. If I wanted it to be that one, it's exactly the same number, 15.6, because that's a 1-to-1. And if I wanted that one, that's the same number as the oxygen. So that's 31.2. Amazing. Mole, 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 mole. Gotta love the mole. That's why we balance equations, guys. That's why. Booyah. It's amazing. Beautiful mole ratio. Yeah. Same number times by 2. I like it. Okay. Now we've done step 2 for 4 people. How cool is that? Now we just need to get out of moles. Step 3. We've done step 2 is use the ratio, which I've used. Sorry, did you mean to turn off your... No. Uh-oh. Oh, that's interesting. You can't see your screen anymore. Oh, I don't know what happened. I clicked a button with my hand, I bet. It's this down here. There we go. Sorry, folks. Yeah, sorry about that. Mr. Duncan, your screen isn't being shared anymore. We can't yet. There you go. Sorry, guys. Don't know how long you guys are up to there. So the great thing is we've done step 2 for everybody. Yeah, times 2, same times 2, all done. I've got moles for everybody, which is amazing. So now all I do is number of moles equals grams over rams. I do this every single time, guys, because I don't want to ever make a mistake on an equation. I've only got one equation in my head, and that's grams over rams. I just reorganize. So I now need to multiply all of these numbers by their MRs. How much does water weigh? Water we've already done. Water is hydrogen times 2 plus oxygen at 16. Yeah, water weighs 18. Times that by 18. What does carbon dioxide weigh? Carbon is 4 plus oxygen, which is 16 times 2. That weighs 44. Times carbon dioxide by 44. How much does oxygen weigh? Oxygen is 16, but it's in a pair. So it weighs 32. So that's times by 32. And I can just run all these numbers through, and you're going to see some magic happen here, guys, which is going to be really cool. Yeah, so let's do 31. By the way, the actual number, rather than, sorry, hang on a sec. That one's wrong. No one pointed that out. There you go. 31.25 is the real number on my calculator. But I'm just going to do 31.3 times by 18. I've used the real number on my calculator, 31.25, not the rounded. Yeah. And I get 562.5 grams. Right. Next one. Let's do 31.25, the real number. Yeah, 31.2 times 32. Going to do this one because it was the same number. Yeah. Wow. 31.25 times 32 gives me exactly 1,000 grams. How fascinating. Blimey, that was a bit of luck. Bonkers. Carbon dioxide. So now I've got 15. I'm just going to get that number back again because I never like using rounded numbers. You should never do it. So 15.625 multiplied by 44. If you'd use the rounded ones, it wouldn't really have mattered. I'm going to get 687.5 grams. Guys, and look at the magic. Look at the magic. Why do we balance equations? $687.5 plus 562.5. Exactly the same mass. It all adds up. That's why we balance equations. For the mole ratio and so that the mass is conserved. Isn't that amazing? I love calculations. They just make me happy. I love chemistry. I'm a nerd. Guys, did everyone get it? How did people get on with it? I've got 10 more minutes. Do you want me to do one more, or do you feel comfortable enough with me giving you a homework and you having a go at a couple? Another example, Oleg? Can I just point out, I'm so disappointed that no one said how amazing it was that all the mass adds up. It was meant to be like one of those groundbreaking moments of like gasps in the room. One more, please. No problem. Okay, let's do question number 4. Aluminium plus oxygen, going back to that one. Aluminium oxide, they're going to have already balanced the equation, which is great. They've given it to you, right? Oleg wants to make 500 grams of aluminium oxide. How much? What mass of aluminium? What mass of, I'm going to actually write it out, aluminium and oxygen will he need? Will he need? Question mark. Okay. Rewrite out the equation because I like writing underneath it. I hope you guys actually look at what I'm doing and go, I can see why he does that. It's more work, but actually it gives you like a scaffold. Yeah, it gives you a scaffold to do. Step number 1, get to moles. Who do I have a mass of? 500 grams of aluminium oxide. That goes there. Step number 1, get to moles. Yeah, moles equals grams over rams. Well, I've got 500 grams. The question is, how much does aluminium oxide weigh? Aluminium oxide contains 2 aluminiums, aluminium 27 times 2 on the periodic table. I've just looked it up, plus oxygen times 3. No idea what aluminium oxide is. 27 plus 27 plus 16 times 3. 102. The total is 102. So I'm going to do 500 divided by 102. That number goes in as the rams. Right, number of moles equals 500 divided by 102. It's actually already on my calculator, which gives me, I'm going to bother with the N. Yeah, that's now going to give me 4.90 moles. Just going to put mole underneath it. I'll put mole next to it. Mole. Right. Step number 2. Use the ratio, which was let's just look at it. It's a 4. I can't see it. 4. Still can't see it. I'm sorry. I've lost my mind. Yeah, which is a 4 to 3 to 2. Let's write that out. And look, I don't like any of that. It makes it really hard to see. Yeah, which is a Just going to do it in a different color just for fun. Yeah, a 2. Going to make it thicker to make it easier to see. 2 to 3 to 4. Okay, that's tricky, that. That's tricky. 2 to 3 to 4. I'm just moving it around to make it fit a bit better. You know what I'm actually wanting to do? I actually want to have it so that the numbers line up with who they are, like that. Okay, so how do I get from 2 to 4? That's easy, isn't it? Times 2. So I'm going to take that number that's on my calculator, 4.9019607884. The whole number, I haven't got rid of it. If I use the rounded, it's not really going to make much difference on this one, but times by 2 equals, I get, so this is the ratio bit using it, 9.80. Right, now the question is, how do you get from 2 to 3? Well, if I divide it by 2, I will get it to the number 1. And then if I times it by 3, I get to 3. So if I go 4.90 divided by 2 times by 3, I get 7.35 moles. I have used the ratio. I should do the other. I should try and color code this, shouldn't I? Yeah, that should really be in red because it just matches the arrow. I don't know what that number was. And nuts. There we go. 9.80. 9.80. Right. So I've used the ratio. Horrible ratio too. I had to get from a 2 to a 3. Divide by 2 times by 3. Yeah? Right. Step 3. Get out of moles. So number of moles is grams over rams. To get to grams, number of moles times rams gets me grams. So how much does aluminium weigh? Aluminium weighs 27. We have used the 4 in the ratio step. Don't make the common mistake of people timesing aluminium up. Aluminium weighs 27. I've gone and there you go. So 9.80 times by 27, the weight of aluminium. So 9.80 times 27 gives me 264.6 grams. Let's go 3 sig fig. 265 grams. Next, how much oxygen do I have? Oxygen is O2. And oxygen is 16, but it's in a pair. 7.35 times 32 for oxygen. 7.35 times 32 gives me 235 grams. What does it add up to, folks? What goes in must come out. Isn't that lovely? If you add the left side together, you get 500 grams exactly. It's nice. I always think it's lovely. You can improve then you get things right. That's the end of our lesson, folks, with 2 minutes to spare. You've got another lesson to go to. I will post your homework. That one. Guys, I know it's a hard lesson. I know. But I promise you it gets easier. It really does. The more you practice, I'll post on the classroom straight away. And you guys can have a go at a couple. I'm only going to give you 4 or 5 of them. You can do them, and then I'll go through those next lesson, and then I'll give you another one again to do for another homework. Guys, you're doing great. I'm so proud of you. Keep working hard. Yeah? I'll see you all soon. See you later, guys.